Well, hello Internet, and welcome to part 13 of my Learn to Program series. In this part of the tutorial, we're going to cover iterables, iterators, list comprehensions, generator functions, and generator expressions. If you haven't watched any of the previous parts of the tutorial, I provide a link to the playlist in the video here, and also in the description below you can find all the code that is heavily commented, as well as a transcript of this video. And I have a lot to do, so let's get into it. Alright, so here we are, and the very first thing I'm going to talk about are iterables. Now, an iterable is a stored sequence of values, or in just a regular old term, it is a list of values. Also, however, whenever we cover generators later in the tutorial, you're going to see also that they can act as an object that produces one value at a time. Now, iterables differ from iterators in that an iterable is an object with a method that looks like this, which you're going to see here in a second. And this is going to return an iterator. An iterator, on the other hand, is an object with a method that looks like this. And next is going to retrieve the next value from a sequence of values. Now, I'm just going to come in here and I'm going to show you some examples, and this will all make sense. You've been playing around with iterators here for a while. You just haven't looked into how they're working. So let's go and create a simple string here, and I'm just going to call this sample. However, in this situation, I want to convert it into an iterator. So I'm just going to come in here and I'm going to type iter like that. And then like this. Now what I'm going to be able to do is come in and grab one character at a time just by calling next on our sample string. And let's go and do it 2 times here just so you can see how exactly this is working for us. And there you can see it stepped through our string and printed each of those individual characters out on the screen. Well, this will probably make even more sense if we come in here and actually add an iterator behavior to a custom class. What I'm going to do is create a custom class called alphabet, and I need to initialize this guy. And how I'm going to do this is I'm going to have all the letters of the alphabet stored inside of it, and there they are. And also I'm going to store an index inside of here, and I'm going to set this to -1 to start off. Now I need to create the iterator method here, and all it is going to do is return our object. Now it's time to come in and define next and how that's going to work for us. And basically what I'm going to do is I'm going to say if self index is greater than or equal to the length of self letters -1, because we are going to be working with indexes that start at 0, of course. In that situation, I want to raise a stop iteration exception. Otherwise, what I'm going to do is come in and increment the value for index, and then also return each individual letter. So just throw self index inside of there, and now we can play with this just like it is where we can iterate through this custom objects that we create. So let's go and create a custom object, call it alpha, and this is going to be of the alphabet class. And now what I can do is go for letter in alpha, print the letter. And there we go. Now we were able to go through and it printed each one of those and finished after it was done processing all of the individual letters in our list. Okay, so that's how we create a custom iterator for a custom class that we have. And also, even though we were previously using a method called keys to iterate through a dictionary, I want to show you also that we can use an iterate through it, because a dictionary is an iterable, where it has that functionality that you just saw built into it. So I'm just going to keep a very simple one here, lname, and let's just throw my name in there. Alright, so what we're going to be able to do now is just go for key in Derek and print out the key, as well as pass in the key to get more information on that. And if we run it, you can see that that indeed works. Keys was never even needed. Okay, so there's a rundown on iterators and iterables and how to create custom classes that allow for iteration. And now we're going to jump into our first problem. Alright, so what I want you to do is to create a class that's going to return values from a Fibonacci sequence each time next is called. And you have all the information you need. And here's sample output, by the way, if you'd like to look at that as well. So feel free to pause the video and take a shot at that. Otherwise, I'm going to jump in here and solve it. So I'm going to come in and just define fib generator, and then we're going to initialize this guy, and I'm going to go self, and first is going to be equal to 0, and then self second is going to be equal to 1. Then I'm going to create an iterator here, and this is just going to return self again. And then I'm going to come in and define how next is going to work for us. And here I'll just come in and go fib num is going to be equal to self, the first value that we have inside of here, and then self, the second value to generate that. And then we'll come in and assign first to whatever second previously was, and then we will get second, and we will assign to it whatever the fib num is, and then we will return, and then we will return fib number. So let's come in here and let's check this out to make sure that it worked for us. And there's, better ways of doing this, but what I decided is I just wanted to do it this way because it's the simplest and easiest to understand. So I'll just come in here and I'll go fib sequence, and I will go fib generator, so we create that object. And then if I want to cycle through these, I can just go for I in, and let's say that I want to get 10 values generated for me, pass that inside of there, and then I can come in and go print and fib, and then if I want the next value from that, I just go next and pass in fib sequence. And if we run it, you can see indeed that it was able to generate those Fibonacci numbers and display them on the screen. So hopefully you got that right. If not, don't worry about it. You just learned how to do something new. And now what we're going to do is jump in and cover a topic that is pretty complicated. So if you don't get it the very first time, don't worry about it. It takes a lot of practice to get used to list comprehensions. Now, a list comprehension is going to execute an expression against an iterable, much like we did with map and filter. And actually, I'm going to use map and filter to compare the differences between map and filter to a list comprehension, so that makes a little bit of sense. Just please note that while a list comprehension is extremely powerful, try not to make list comprehensions that are hard to figure out for others or for future version of yourself. So let's say we wanted to multiply 2 times every value with a map. How would we do that? Now again, if you didn't see the previous part of the tutorial, this isn't going to make any sense, but what we're going to do here is generate a list and map, and with map, you're going to pass in a lambda in this situation, and we're going to say x, and then what we're going to be multiplying times. So x times 2, come out of the lambda that is surrounded by parentheses, and then we're going to say range, and we'll say we want to generate 1 through 10. We want to multiply all those out. Well, boom, and there you see how easy that is. Now let's see how we can use a list comprehension to do that. Now a list comprehension by default is going to generate a list, so we don't need to come in here and do anything with that. And a list comprehension is going to be surrounded with these square brackets in comparison to parentheses. And here you're going to say something like 2 times x for x in range 1 and to 11. All right, and run it. You can see we got exactly the same results. So what we were able to do is we just threw that expression in there instead of this one, and there is range just like we have range up there. Okay, so that's the difference between map and a list comprehension that does precisely exactly the same thing. Now what I'm going to do is compare a list comprehension to a filter. That is going to work much the same. So we need to convert our filter into a list, and then we're going to throw lambda inside of here again, and we're going to say x, and then x %, 2 or modulus, whatever you want to do, is not equal to 0. Come out of that, and then the range that we want to work with, and it's going to be 1 through 10, and run it, and you can see it cycled through all of that information and popped out only the odd numbers. Now let's go in and see how to do this with a list comprehension. I'm going to do something quite similar. Here we'll say x for x in range and 1 and 11, And the difference is we are going to put the filter on, or the condition on the right side versus on the left side whenever we work with list comprehensions. As you can see, everything, maps are going to be translated to the expression being on the left side. Filters are going to be translated as if they are on the right side. And once again, these are in square brackets. And now we'll come in and go if x modulus 2 is not equal to 0, and run it. And you can see we got exactly the same results. So let's do some more complicated things. Once again, this might not make sense originally, so don't worry about it. We are also going to be able to use a list comprehension that can act like a map and a filter all on one line. So what I want to do here is generate a list of 50 values and then take them to the power of 2 and return all that are multiples of 8. So let's actually type that out. So we'll say generate 50 values, and what else are we going to do? Take to the power of 2 each one of those items, and then return multiples of 8. Okay, so that is what we're going to do here with our code, with our list comprehension. So how are we going to do it? We're going to say print, and then list comprehension, square brackets, and what do we want to do? We want to take it to the power of 2, so we're going to go I to the power of 2, and then we're going to say for I in range, and we want to generate 50 values. And then we put our filter here, or our condition, at the end. So we'll say I %8 equal to 0, and run it. And you can see indeed that it went in there and generated all those multiples of 8 for all those different guys that we went in there and threw in. So pretty cool stuff. Another thing that is pretty neat is you're going to be able to have multiple for loops as well. So let's say we want to multiply all values in one list times all values in another list. Do that. List comprehensions are extremely powerful, like I said before. So let's say we want to go x times y for x in range, and we'll just keep this simple. We'll go 1 and 3, and then outside of that we'll say for y in range, and we'll throw 11 to 16 inside of here and run it. And you're going to see that it went in there and multiplied 1 times 11 the whole way through 16, so 15 actually, so that's what you see there. And then it went in and multiplied 2 times all of these values, and that is how we get our final list result. So pretty cool stuff. Another thing that's even more powerful is you're going to actually be able to put list comprehensions inside of list comprehensions. So let's get rid of all the mess that we generated here. So what do we want to do with this example? Let's say we want to generate a list of 10 values, and then we want to multiply them by 2, and then we want to return multiples of 8. Alright, so how are we going to do that? Well, we'll just come in and call for print, and we'll say x for x in, and then we'll throw another list comprehension inside of here, and we'll say I times 2 for I in range, and we'll throw 10 inside of there, close off that list comprehension, and then we will filter this, and we'll say if x modulus 8 is equal to 0, and run it, and you can see that it went in and did that. So it's just never ending, the different things we can do. And now it's time for a problem. Alright, so this is going to be a hard problem. What I want you to do is generate a list of 50 random values between 1 and 1000, and then return those that are multiples of 9. Now to do so, you're going to have to use a list comprehension inside of a list comprehension, which is what I just covered. So pause the video and take a shot at that guy. Otherwise, I'm going to show you exactly how it's done. So we're working with random values, so I'm going to come in here and import my random module. Then I'm going to say print, and I'm going to say x for x in, and then inside of here I'm going to generate the random values. So I'm going to say random rand int, and I said that I want to have random values between 1 and 1000, so that's how we're going to do that. And then I'm going to say for I in range, and I said that I want to have 50 values generated, so there's 50 values generated, and let's get rid of that altogether. Then after the list comprehension inside of list comprehension, I then want to find values that are multiples of 9. So this is going to change every single time we run it because it's completely random. So there that guy is. Take that all in. If you got that, great job. If you didn't, definitely don't worry about it. This is a pretty complicated problem. And let's go and run it. And you can see right here that it went and generated these values. And if I run it again and again, you're going to see that all those values are totally random. So pretty cool stuff. Like I said, list comprehensions reserve a lot of practice to get very good at, and it's going to take some time to get used to them. But I think you can see that it's definitely worth investing your time in them because they are extremely powerful. Let's go and show you one more example actually. List comprehensions are also going to make it very easy for us to work with multi-dimensional list. So let's go and let's create one. So there is our multi-dimensional list, and let's say I want to come in here and go print, and I want to print this column right here, 2, 5, and 8. The list comprehension is pretty easy. You just go column, and it can be anything. It doesn't need to be called column. And I'm going to say 1 because this is the ones. These are 0, 1, and 2. And then I'll say 4 column in multi-dimensional list, and you can see it printed that guy right out for me. So very, very easy to work with. And even better yet, we could go and print out the diagonal 1, 5, and 9. So let's say print, and it's going to return a list also, which is very useful because that's what list comprehensions do. So here I'm going to say multi-list, and I'm going to say that I want to get the indexes based off of calling each of those individual guys. And I'm going to say for I in range, and then I'll take the maximum number. So we'll say length of multi-dimensional list, and if you do that, you're going to see you get a list back that is 1, 5, and 9. And how that works quite simply is the first time through, obviously, it's going to give you the 0, 0 position. Second time through, it is going to give you the 1, 1 position, and then it's the 2 and 2 position. So really cool stuff with list comprehensions. Now let's jump in and talk about generator functions. Now remember back at the beginning of the video, it wasn't that long ago, I talked about being able to generate individual values one at a time. Well, a generator function is going to return a result generator whenever you call it, and then you're going to be able to suspend or resume during execution of your program to create results over time rather than all at once. So this is the example right here. And you may ask yourself, well, why on earth would I want to do that? Well, we mainly use generators when we want to get a very large result set, large number of results. But we don't want to slow down our program by creating all of those results all at one time. So let's say we wanted to create a generator that's going to calculate primes and then returns the next prime each time we ask for it versus getting it all at once. So I'm going to say, I'm going to create a function here called isPrime. You've seen it before, and there that is. Then inside of it, we're going to have a for loop that is going to iterate through all of the results that we pass inside of it. It's going to start at 2, and it's going to go up to whatever the number was that you passed inside of there. And then we're going to check if any division has no remainder. And in that situation, we know that we have a prime number. So to do that, we'll just go if num modulus I is equal to 0. And yes, there are shorter ways to do this. I'm just trying to keep it simple. So in that situation, we're going to say false. And if none of those are returned, if it hits this return, that means it jumps out of the function altogether. That means if none of the things came back as positive, in that situation, we know we do have a prime. So we'll say return true. Now it's time for the generator part. So I'm going to call this gen primes. And inside of here, you're going to type in the maximum number you want to generate up to. We're going to have a for loop inside of here that's going to cycle through primes from 2 to the maximum value you requested. So we'll say in range, and I'm going to say 2 to the maximum number. And then each time through, it's going to call for isPrime to execute, and it's going to pass each of those values inside of it. We need to go if isPrime. And then we're going to use yield, which is what makes this a generator. And whenever it's called by next, it's going to return the next result. And to do it, you just say yield and number 1. It's going to make more sense here whenever I use it here in a second. So what I want to do is I want to come in here and create a reference to the generator. So I'm going to say prime is equal to gen primes. And then let's say I want to go up to 50. And then what I can do is go print, and we'll say prime, and then we'll go next, and pass prime inside of it. And then let's do this a couple different times, right like that, and run it. And there you can see it cycled through, and each time it was called, it generated a new prime number over and over again. So pretty cool stuff. And now to finish off, I'm going to cover generator expressions. Now, generator expressions look just like list comprehensions, which you just saw, but they return results one at a time. That's the reason why they're called generators. And the other difference is they're going to be surrounded by parentheses instead of your square brackets, which you had with list comprehensions. So let's come in here and create one. And this guy is just going to double a whole bunch of values. And you can see there's parentheses. So I'm going to say x times 2 for x in range. And we'll say 10. Now what I'm going to be able to do is just come in and go print. And we'll say double, just to keep this simple. And then we will call next on double. So there's double. Whoops, spelled double right. And then we will come in and we will grab it again and run it. And there you can see, indeed, it worked out perfectly. You're also going to be able to iterate through all of these results as well. So we can come in and go for num in double and then print num and run it. And you can see it got all of the results in that situation. So there you go, guys. That is iterables, iterators, list comprehensions, generators, and generator expressions. Whole bunch of things for you to practice with. And like always, please leave your questions and comments below. Otherwise, till next time.